Now, hey, this means that we have 95% of confidence that the true value of mu, hey, the true value of mu will lie within this interval from minus to positive 1.96. Okay? And how to interpret 95%? This means that if you construct 1,000 times, hey, for one time, we are 95% confident. If you, for one confidence interval, and you should say, oh, I'm confident. I'm so confident for 95%. Okay, and 95% is a very good chance, means a very good chance that mu will lie within this interval. That's one confidence interval. Okay, alternatively, if you construct such interval 1,000 times, hey, this time you use data, you use different combination of data, you use, okay, to interpret. This implies that, where is my pen? Where is my pen? Hey, where is my pen? The pen I just bought for $1,000. Hey, where is my pen? Hey, oh, here. The implication, the meaning of 95% implies that if you is that you used 100 samples, okay, like x1, x2, all the way to xn, 1,000 times to construct the confidence interval by the formula and obtain $1,000 confidence interval by the formula. By the formula. Okay? Now you have such interval. You have 1,000, then 950 such intervals will cover the true value of mu. Okay? For example, confidence interval, confidence interval, confidence interval. Hey, this failed to cover. This one failed to cover. Okay? Failed to cover the true value of mu. But others do, right? Okay? All the way to this one, right? 1,000 of them. And here, this is the true value of mu. 1,000 confidence intervals. Okay, 950 of them cover the true value of mu. Okay? All right. And I'm going to demonstrate using, and now I'm going to demonstrate using the Microsoft Excel. Microsoft Excel. And I hope you can follow my demonstration and do the simulation by yourself at home, back home, okay? So let me show you Microsoft Excel. And later, I will also upload the PowerPoint file, the PDF file, and also the Excel file, so that you can follow my demonstration and do the simulation, do a similar simulation yourself back home. Okay? So let's go to the Microsoft Excel. Here. Yeah, here. Now, hey, now the interface is in English. Okay? New file. New file. Close. Close. Hey, what happened? Hey, what happened? Hey, what's wrong? Hey? Again. This time I will use my fingers. Yeah. Yeah. Okay. And we'll go to the toolbar and click the data. Hey, here, data. Here, data here. Look for a data icon here. Okay. And there is also icon for data analysis on the right hand side. Data analysis. Hey, let me screenshot. Let me use the screenshot, okay? Here. Hey, what happened? Yeah, here. This one. Here. Okay? And if you open the Microsoft Excel and you don't see this, then you have to add manually by yourself. How to add? Here. Go to click the file icon here and go to here, more. Hey, here, look for more. Hey, here, more on the bottom left. More here, option. Hey, option. Yeah, and add in and click here, add in. All right, add in, click. Okay, and I think it is, yeah, Excel add-ins, and go. And analysis tool pack. Screenshot. What happened? Yeah, this one. This one. Yep. And choose data analysis tool pack. Okay. All right. So now we can use it. Okay. Data analysis and a random number generator. Random number generation. Yeah, here. This one and this one. Here. All right. Okay. And normal distribution. And 300. 300 and 1,000. You can do it yourself. Okay. Here. And a screenshot again. Hey, please be quiet, okay? Don't talk all the time. Yeah. Here. Okay. Normal distribution. Oh, not yet. This one. Normal. And for example, the population is the height of TKU student, boy student. What happened? And the mean height is 176, okay? Mean height 176 and 4.5, the standard deviation. Yeah, and a screenshot. Here. Draw. x1, x2, all the way to x300 from normal 176, the mean height of TKU boy student, and the standard deviation 4.5 squared. Okay, okay, 1,000 times for 1,000 times. All right, and this is the population of TKU boy students' heights. All right. Okay. Now let's go to the Microsoft Excel. Yeah. Okay. Take a minute. Wait a minute. Wait a minute. Wait a minute. Yeah. Okay. How many times? 1,000 times. Hey, this is the first. This is the first. This is the first x1, x2, all the way to x300. And this is the second sample. This is the first sample, the highlight is the first sample. Second highlight, second sample from, hey, x1, x2, all the way to x300. Understand? x300. How many such samples? We have 1,000 such samples. 1,000, you see that? 1,000. We have 1,000 such samples. Each sample has 300 observations. Observation number 1, x1. Observation number 2, x2. And all the way to observation 300, x300. Okay? Hey, you might question 1, 2, 3, 4, 5, 6, 7, 8, 9. Only 9 observations. Why do the professors say it is 300? Actually, it is 300. Look. Hey, let me pull to the right. It is 300. Okay? So we have such samples. We have 10,000 or 1,000 such samples. And each sample contains 300 observations. Now we have 300 such things. All right. Okay. So we will have x1, 1,000 such samples. Okay. So you. Okay. Now it is time to construct the confidence interval. It is time to construct such confidence interval. So here, what happened? Hey, Yeah. Here. And let's go to, hey, what happened? Oh, here. See? See? What's wrong? Okay. Yeah, here. Now, it is time to construct confidence interval. What is the confidence interval? The confidence interval formula is here. This one, okay? This one, all right? This one. X bar minus 1 point, okay, let me put it here. X bar minus 1.96 square root of n sigma. And on the right hand side, that's the confidence interval. All right? Let me zoom in. What happened? See? Hey. 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 Okay. Forget it. X bar in Excel, it is average. AVERAGE. All right? Sorry. Equal AVERAGE for X bar. A1 to KN1. A1 to KN1. Okay? Minus 1.69 times 4.5, which is the sigma, value of sigma, square root of n, SQRT. Right? SQRT 300. And equal AVERAGE, okay? A1 to KN1. A1 to KN1 minus plus 1.96 times 4.5 divided by SQRT on 300. Okay? Now we have the first confidence interval. This is the confidence interval, all right? How can I roll to the right? And I have to wipe this off. All right? And now double click. Now double click to finish the rest. Double click. Yep. And double click. And now this is the first sample and the first confidence interval. All right. And now I'm going to determine whether this confidence interval covers the true value of mean. Equal this bigger than 176. 176. But oh, sorry, this is smaller than 176, and this is bigger than 176. The answer is yes. Hey, now this interval, this implies that the first interval covers 176, which is the value of mu. And this implies that the seventh failed to cover mu equal 176. Okay, and let me screenshot. Yeah, here. Paste. Yep. And this one. Paste. This is x bar minus 1.69 square root of n sigma. Okay, and this one is x bar plus 1.69 square root of n sigma. Okay, now it is time. Okay, it is time for the it is time to verify. It is time to verify the theory. I said, how many confidence are there? How many confidence intervals are there in the Microsoft Excel now? How many? 1,000. It is 1,000. 1, 2, 3, 4, 5, all the way down to 1,000. And how many of them will cover the true value of mu? 950. Understand? 950. Okay, I will sum if it is 1, then it covers. And if it is 0, it does not cover. So if we sum this column up, we will have the sum which is very close to 950. If it is not, hey, if it is not 950, I will give you, every one of you, 100 as the final score. Okay? Okay, anyone want to challenge me? What if I fail? The sum is not close, is very far away from 950. If you want to challenge me, and then later the number is not 950, I will give you 100. But if I make it, if I succeed, then you don't have any raise, any lift in the final score. You don't have extra shift in the final score. You want to challenge me? If I fail, you win 100. If I succeed, you win no extra bonus. Hey, Sophia, you want to challenge me? You know what I mean? You know what I mean? Yep. How to challenge? You want to challenge me? Hey, hey, no cell phone. You owe me 10 to 15 points. Okay? Now, it's a judgment day. Okay? 最后审判。Let me sum them up. Sum. Hey, let me sum them up. Equals sum. If I sum this column up 1,000, hey, if I sum them up, you see this? 955. It is a number very close to 950. Okay? Very close to what I just predict. Yes. It is a simulation. And 950 means the theoretical prediction. And now this is the simulation in practice. And the number 950, 955 are very close. Okay. To the answer, right? Yeah, close to the answer if you divide it by 1,000. Yeah. And turn them into percentage. Very close. Understand? And I want you to hey. I want you to repeat this simulation at back home. Okay? I want you to repeat. Okay? You can change. If you wanted to do the simulation at home, you can change. Hey, you can change. What you can change is the hey, you can make it 500. You can make it 500. All right. And 1,000, you can make it into 2,000. And you can also change the value of mu and sigma. Hey, this is mu, and this is sigma. You can make it 162. Hey, the mean height of a TKU girl student, 162. And here, you can make it into 3 for your demo, for your simulation. Hey, you should do this back home. Understand? And I will upload the Excel file so that you can follow my simulation. And prove that the ratio of success is 95%. Okay? It's 95%. This is the value of sigma. The value of sigma. This is the value of mu, and this is the value of sigma, okay? And this is the value of n, right? Understand? Safe. Yeah. Do it back home. Now, here. 95% divided by 1,000. Now it is very close to wait a minute. Very close to 1,000, about 95%. Okay, 10-minute break. Okay, demo of confidence interval. Hey, silence. Demo of confidence interval. Okay. Okay. I have to generalize. Now we know how to construct a confidence interval, right? And I wanted to generalize. Yeah. So, did we stop here last week? Did we stop here last week? Did we? Hey, did we stop here last week? No? Yes? Hey, now, oh, sorry. I had to, generalize this. Yeah. Let's take a review where we stopped last week. Okay. Mu has probability 0.95 divide in the confidence interval. Okay. Now I want to make the probability more general. Okay. This time it is not 95%. This time it is 1 minus the 0.05 times 100%. Hey, the same thing. Hey, 95% is equal to the parenthesis 1 minus 0.05. Okay, times 100%. Hey, the same thing. The black one and the red one is the same thing. Are the same thing. Now they are the same. Okay. Yep. And what is this? What is 1.96? Hey, look at the figure. This is 95%, 0.95. And what are the critical values? So if this part take 95%, the two-tail part takes 0.05%. Okay, and it is 0.025 on the right and 0.025 on the left. Okay, and here we have a notation for 1.96. It is defined 1.96. It is defined as C sub 0.05 divided by 2. Okay, why? Because the area right to this number is 0.05 divided by 2. The area here right to this point is 0.05 divided by 2. So we have a notation for it. 1.96 equal is defined as Z sub 0.05 divided by 2. Or you can just write 0.025. But usually, commonly, it is commonly used. This one is more used more often. Okay, 0.05 divided by 2. A Z subtitle. This is a subtitle. Okay. But okay, so what if it is 90? What if it is 90? Then if this is 0.90, then the two parts on both sides, the two tail on both sides takes 0.10%. So the critical value here is 1.645. Right? So what is the notation? The notation here is Z sub 0.1 divided by 2. Okay? So here, this thing here is 1 minus 0.05. And this is 1 minus 1 minus times 100%. Okay. So now you see this. If it is 1 minus 0.10, then here it is 0.10. And so is this. Okay. And now if it is 1 minus 0.05 here, then here it is 0.05 here. Okay. So if it is 1 minus alpha, so what is this? The critical value here should be Z sub alpha divided by 2. Okay. So I should better use this. Okay. This one should be 1 minus alpha times 100%. This figure shows how we can shows you the way to generalize. All right. It is 1 minus alpha times 100%. So if here it is, hey, if it is 90%, then this alpha should be 0.10, okay? And then here, this one should be 0.10, okay? If this is 0.05, then this is 0.05, okay? That then this figure show how we can generalize. So 95%, 0.0905. Now here it is 0.05 here. And how to generalize? This is how we generalize. Next slide. Okay. Yep. So to generalize, okay, the 100% times 1 minus alpha confidence interval for mu is, hey, this time we don't use 1.96 or 1.96645. Now we use the notation z sub alpha divided by 2, x bar minus x bar plus. Okay. Okay. The confidence interval for mu is here. Okay. Where number 1, 2, 3, 4 are all available in practice. X bar is available from the sample which you draw, and sigma is known by assumption. And z sub alpha divided by 2 is available from table. And is the sample size, which is predetermined. Okay. Now I cannot use Chinese letter here. Where? So the confidence interval can be obtained by using 1, 2, 3, 4 because they are now all available. Okay. This is the lecture note for this week. Okay, and we also make a generalization on and we obtain a general formula. All right, this is the general formula, and this time the confidence level. A confidence level can be anything between 0 and 1. All right, the confidence interval can be anything between 0 and 1. Okay. Okay. So theoretically, we can construct the table, construct the confidence interval because 1, 2, 3, 4 are all available. Hey, now I have a question. I think 1, 2, 3, 4, one of them is probably unavailable in practice. Which one? The first one, second one, third one, and fourth one. And raise your hand if you know the answer. One of them. Which one? One of them is unavailable in practice. In general, unavailable. Hey, raise your hand for extra bonus. Which one of them? Yep. Very good. Very good. This is known by assumption. Okay? This is available from data. Hey, you always have data if you can draw at random, draw them. It is always available. Okay, and this is available from the data, and this is the sample size, which is predetermined by you, by the investigator. Okay, and then this assumption is very questionable. Okay, very questionable. Unfortunately, okay, unfortunately, 很不幸的 the true value is often unknown. In practice. Okay? Unfortunately. Okay? Without this, without the true value of sigma, unavailable. Okay? In practice, in this case, we can use the fake value of sigma to serve as sigma. What is the fake value? The fake value sigma, the fake sigma is given by estimated value of sigma is given by sigma hat. When you see hat in the notation, statistical notation, A, also available from data. Okay, it is also available from data. Now we don't have to worry. We don't have to worry about the true value of sigma, even because in this case, where the value of sigma is unknown. The true one is unknown, then we can use the fake one. Okay, the fake value, or you can say estimated value of sigma is given by this. It's given by 8 little f. And now we use the notation sigma hat. Hey, if you see any hat in statistical notation, this hat always means estimated or fake. Okay? Ready? You finish? I'm going to the next page. Any question? Do you have any question? Okay. If we don't have any question, then I will go to the next page. Okay. Okay. Now, the confidence interval. For mu, when sigma is unknown, is given by x bar minus, hey, this time give more space here. Give more space right to x bar. And here it is ace. Okay? Because it is now, it now serves as the fake value of the sigma. Okay? It now serves as the fake value of the sigma. Okay? Because now we don't have the true one. All right? But this time you see I give more space here. This time I give more space here. Here. Oh, much longer. Much longer. Because the notation will be different again. Right? I use black pen to signify the difference. All right? Here it is t n minus 1, right? Alpha over 2. And here it is t n minus 1, alpha over 2. where t-distribution. With degrees of freedom. Okay? And if this is alpha, 1 minus alpha times 100, then this one should be alpha divided by 2. And so is this, alpha divided by 2. And here it is symmetric about 0. And this is t minus 1 alpha over 2. And this is minus t n sub 1 alpha divided by 2. Okay? You see that? And student t distribution. And we let us Google for the student t distribution. All right? Okay? So let us go to the student t distribution, okay? Let's Google. What happened? Now here, look at this t distribution. Student t distribution here. Hey, Google. It is not Google. It is Microsoft Bing, not Google. Whatever. Okay. Student t distribution. Here. Yep. Yep. T is the same as n. Hey, T V here is the same as n in our lecture note. All right. Hey, you see this? The yellow one, V or N, V is N, okay? The same. The degree of freedom. The yellow one is the T distribution with the degree of freedom 1, N equal 1. And the purple one here is the T distribution with the degree of freedom N minus 1, the degree of freedom 2. Okay, so N is 2 here, right? And what is the color? The blue one is the T distribution with the degree of freedom 5. So N is 5 here. And what if N or v goes to infinity? Raise your hand if you know the answer for extra bonus. I will know. I will give you extra bonus. Hey, raise your hand if you know the answer. What happened if v goes to infinity? What happened? Let me shoot. Let me copy this figure and put it into our lecture note. Here, the same as n. In our formula, right? And know that when n goes to infinity, the t distribution, all right? T infinity equal T infinity equal the standard normal distribution. The limiting distribution of T is the standard normal. Hey, they are cousins. They are very closely related. Yo, hey, don't use a cell phone all the time. Focus, attention, all right? All right? Yeah. What? PS. What is PX? Probability. Um, it is a notation for the y axis. The scale does not change. The scale does not change. Okay, when n goes to infinity, what change is the curve? Now it is the black one, and this is the same as the normal curve, same as the standard normal curve. Okay, the same as the standard normal curve. Okay, you see that? Yep, they coincide. Right? Coincide with the standard normal curve. When n goes to infinity, the black one, I mean the black curve. See that? Okay. Now let us summarize. To summarize, and let's go to the table. Now let's go to the table. Let me introduce more about the T distribution. Hey, T distribution and the normal distribution are relative. Okay, they are closely related, or you can say they are cousins. All right. Gossett, the one who established student T distribution is well, not here. Oh, the photo is not here. Gossett, T distribution. A British chemist. Hey, he's not a mathematician, nor a statistician. He's a chemist. 化学家. Okay. William Gossett. This guy. This one. This is the guy who established or who found T distribution, and he has a contract with this company where he works. He has a contract with his company, okay, where he worked, okay. The contract says that he cannot publish any number or any data in public, okay. Any data from his company is prohibited. You cannot publish any paper about the data in his company. Okay, so he did not dare not to use his real name. He used a fake name, a pen name, a fake name. He used the name student. He don't use his name, real name Gossett. He used his fake name, student. Okay, student. Okay, so to celebrate his contribution, the statistician use T distribution to celebrate his contribution. All right, and the formula for T distribution is more complicated than the standard normal distribution. Okay, and the table. Let us go to the table. Let's go to the table. Table. Yeah, here. Yeah. One tail. Yeah, here. Let me use this. Copy and paste. What happened to the? Yeah, here. Yeah. You can go to your appendix and look for the table of T distribution, and this is the critical value. Critical value. Here. Here. For example, this one. This one means the T distribution with a degree of freedom 5, right? And this is 0.95. So this here is 0.025. And so is this 0.025. So this one is This one is P sub 5 0.05 divided by 2. And this means that P with a degree of freedom 5, all right, bigger than the value is this, or you can say P5 bigger than 2.570582. It is 0.025 equivalently. All right. Okay, let me generalize. Let me generalize. All right, here. To generalize, to summarize. To summarize, the confidence intervals for mu when one minus alpha times 100% confidence interval. Confidence interval is given by x bar minus z sub alpha divided by 2 n square sigma when sigma is known. And here, when sigma is unknown. Right? Is unknown. To summarize, what time is it? Oh, local time. Yes. I will make up for four students who didn't make it in the previous hour. What happened? The iPad and cell phone failed to work. Here. This one. Hey. I should shut this down. I should shut this down.